various metrics for each of those servers, WebSphere application servers. Moving on, next I'll talk about how we can use these various OPM dashboards and configurations to identify some of the critical issues that you might encounter in your database. We'll first look at how to identify if there has been any disk bottlenecks that are noticed on your database. Now the first place that we would go to identify any issue is the overview dashboard. On the overview dashboard, as we have seen earlier, there are various sections which will provide us data categorized for various system metrics. And there we also use baselines in identifying, okay, between 4 p.m. and 5 p.m. today I have seen a disk bottleneck. Let me compare to this performance metrics between 4 and 5 p.m. against my baseline time and try to identify what has changed between my baseline and now that I'm now hitting the bottleneck in terms of disk. So on this screenshot, we can actually see that the I/O time has increased a lot. The baseline average I/O time percentage was 69%, whereas in the time slice that was selected, it is 96% I/O. So that is giving us a clue that there could probably be some issues with I/O, and hence this is probably a disk issue. And then we'll drill down further and see what could have caused that. So from the overview dashboard, we move to the buffer pool and I/O dashboard. Because the performance metric that we saw, which was in terms of the I/O, is related, is shown in further detail on the I/O dashboard. Now we have noticed two things on this overview dashboard. One is the I/O time has increased from 69% to 96%, and second, the pool I/O has increased from 10.2 milliseconds to 17.6 milliseconds. And once we move from the overview dashboard to the buffer pool and I/O dashboard, we get further details on what was the exact activity that was going in terms of actual physical on the database. At the baseline time, we see that there were 36,141 physical pages that were read per minute, whereas in the current time slice it shows 212,406 pages per minute being read. This necessarily doesn't mean that there is an issue, it just could probably mean that there are more number of sequels that could have been executed at this particular time. So the next thing that we will observe is the average read time per page on this particular dashboard. It says that the average read time per page that has been fetched is also gone up. Now this is now a problem, because not just we are picking up more number of pages, but for picking up more for each page on the database, we're also spending much more time than earlier, which was our baseline time. The average read time now is 0.018 seconds, whereas on the baseline time it was much lesser. So once we go to the tab on the dashboard, which is called the table space, we'll try to identify if there has been any change on the table space that has been done which could have caused this. Again, we compare the current value with the baseline value, and we notice that there is no single table space where this particular issue is there. It's just that there are a lot many pages being picked up from each of those table spaces as compared to the baseline. So this is not a case where a lot of I/O is happening against only one table space on your table, and so yeah, nothing would probably need to be done on the table space side for this particular case. Then next we drill down further into the tables tab to identify if there was any one particular table where this issue has occurred, because of which this I/O time has increased so much. We compare again, and then we see that the number of rows read in each of those tables hasn't varied greatly, the time slice that we have selected. And so this also doesn't look like an issue with respect to bottlenecks at the table level. Then we go back to the buffer pools tab to see further in terms of, okay, is there any, now that we have seen that there's no issue with respect to table space or tables, is there any issue with respect to the buffer pool hit ratio or the IO ratios for those buffer pools? So on this slide, we see that the pool hit ratio is 78.31, whereas for the baseline, it was at 94%. So now we have identified one issue, that the buffer pool hit ratio utilization has actually come down from 94% to 78%, and this probably could be one of the reasons why the IO times have so vastly increased. The next slide is just summarizing what all we have seen on this particular dashboard, which is the buffer pool and IO dashboard, and how we can infer the cause of the issue. On the overview dashboard, we have seen that the percentage time spent on IO has increased from 69% to 96%, from 10 milliseconds to 17 milliseconds increase in the average pool read time. The buffer pool and IO dashboards show us details about the buffer pool reads per minute. And we also saw that the data hit ratio dropped from 94% utilization to 78%. And there was no apparent table space or tables which showed any hotspots with respect to performance. So some of the things that could cause this particular thing are probably some particular SQL has ran additional during this time, and it was a bad SQL wherein it was hitting that active table space again and again. Probably the buffer pool configuration, there was an issue with respect to the buffer pool configuration, and that's why the buffer pool data hit ratio has dropped from 94% to 78%. Now, when we go back on the buffer pool tab of the data, of the dashboard, we notice that for one of the buffer pools, which is the IBM default BP in this particular case, the size of the buffer pool seems to have changed quite a bit from the baseline time. Now, this could probably answer the issue that we have seen in terms of the buffer pool hit ratio getting reduced from 94% to 78% utilization. So this is one issue that we have seen, which is about how we can identify any disk level bottlenecks that we can observe on database performance using the OPM dashboards. It's currently 3:47, and I'll run through one more case to identify SQL issues before we end the session. I'm sorry, will I go through the locks on how to identify locks and what issues cause that particular lock, and see how OPM dashboards can help us. Now, we have from the overview dashboard, we moved to the workload dashboard because we have seen a few alerts on the workload section of the overview dashboard, and then we observe that in terms of transaction throughput and row throughput, there has been a sudden change, a drop or a sudden increase at certain instance of time. The screenshot shows that the rows read per fetched row didn't completely go to 0. Something was still being read, but which was much higher than the other times. So as you can see in this particular time slide on 27th May, somewhere between 1:10 p.m. and 1:23 p.m., there's been a sudden spurt in terms of the number of rows read per fetched row. Meaning for every one row that we want from the database, how many rows were actually read from the database itself into memory. This could possibly explain why there is a drop in statement throughput at that particular time, and also the transaction throughput at that particular time. The number of transactions that were processed had suddenly dipped. We'll try to identify how we can find out the root cause of this particular issue. So on the overview dashboard, we look at the time. There's a section called the DB2 time breakdown percentages, and again we compare the times that were there between the baseline time and the current time, and we observe that the baseline average was 4.74% in terms of lock weight, whereas the current in the current time slice that we have selected, it's about 46%, which is extremely high, which means there have been more number of locks that have occurred in this particular time slot. So on the bottom section of the overview dashboard, we go to the locking dashboard, wherein we try to find out more details on what exactly is happening, and then we find that the average wait time per lock has also increased from 115 milliseconds. It has now gone up to 2,359 milliseconds. And then we identify, go ahead and try to identify what exactly has caused this particular lock wait time to increase so much. The locking dashboard mentions that in the time slice that was selected, that 1 hour time slice that was selected, there have been 996 locking events that has happened in the particular case, a screenshot of which I have put on this particular slide. At the same time, during the baseline, we see that the maximum block time that was there was much lesser as compared to the current time slice. Right? The block time was just 0.02 seconds, whereas in this time frame we see that the maximum block time was 4.78 seconds. So there was some SQL or a set of SQLs that got blocked for a high amount of time, thereby showing the drop in the transaction throughput on the server. And from there, we'll go further into looking at the statements for that particular lock. So on this particular lock, what all statements are causing that particular lock, and then we can identify that this particular statement that we have identified in the lock has an isolation level of RR, which is repeatable read. But at the same time, in the next slide, we'll observe that the number of rows read in this particular SQL are more than 2 million rows. So when a particular SQL is reading about 2 million rows and we have an RR isolation level that is attached, this could cause certain performance issues because no other SQLs will be able to execute anything at that particular time, because more than 2 million records in your database are actually locked, and the other SQLs which might need to access those rows are waiting, and hence the increase that we see in terms of the lock weight. So in this particular case that I have taken, yes, the issue was with RR, and since the SQL was fetching a high number of rows, we probably might have to change the isolation level or change the SQL itself so that it doesn't read so many records in each execution. So I have taken these two cases, which is the disk usage and the locks, to showcase how OPM can be used to identify performance issues on your database and then help you in analyzing and then probably fix those issues. So in summary, the OPM overview, workload and system dashboards are a good place to start to identify performance issues, and depending on the type of issues, we can drill down into further dashboards like the buffer pool locking or the logging dashboards. SQL statements can we can view them on the SQL dashboard and use the Optim Workload Query Tuner to identify any issues with the SQL and then use OQT to actually tune that particular query. And Extended Insight gives a little more information with respect to your entire setup and not just the database layer itself. So having mentioned that, I now hand it over to Mohini so that we can take up any questions that might have come up.